Hello and welcome to the video. This is an OpenTX quick tip. Now there are lots of OpenTX quick tips on the channel. If you look at the OpenTX Mix School, there's lots of information in there about how you can do some amazing things with OpenTX on things like the Taranis, QX7 and other FrSky radios, as well as other radios that run the OpenTX system as well. This one is a little bit different, and I need to give a massive shout out to a gentleman called Clive Hall. Now Clive rang me out the blue. Clive has been modelling since the 40s and he is an absolute wealth of information. And I love getting calls from people like Clive because Clive taught me an awful lot and asked me to create this video to kind of share this information, and specifically around how you can use throttle curves in general actually with things like glow engines to linearize the throttle output so that the output you get from the glow engines is a little flatter, and also to do some neat tricks to synchronize multiple glow engines on a model without having to resort to clipping bits off props, messing with high and low needles and mix settings and those things as well. Now I need to confess here, I am not a glow engine expert by any stretch of the imagination. I came into the hobby and pretty much pioneered and stayed with the electric systems. So all of the information in here, if there's any inaccuracies or problems, they will be my fault. The model memory and stuff that we're going to look at is one that has been supplied by Clive. So the first thing we'll talk about then is how you can linearize the output of a glow engine. And what Clive has done is very cleverly, he's actually added a curve into the main throttle control that controls all of the throttles. Now if I actually look at curve CV03, it looks like that. And in Clive's experience, what he's saying is that that kind of curve, you've got the numbers here on the right hand side if you want to replicate it, that kind of curve is great for giving you a much more linear output from a glow engine. And by adding it onto the input, that means that all the glow engines are going to be modified by this curve and going to work a lot better. So that's going to be a handy thing to know if you're using one similar glow engine. And that isn't going to stop you from doing all the standard stuff with a glow in terms of making sure that the mixture's right, that the high and low needles are set properly and all of that goodness, but it does mean that you'll get a more linear throttle output. The other thing that he's done, which is really clever, is talked about how you can synchronize multiple glow engines on a model. Now this isn't a problem we tend to find as much in electric systems, because once you have the ESCs calibrated, as long as the props are pretty much the same, then you're going to get pretty much equal thrust each side of the model. So if you're going to fly something like a Mosquito, maybe a Messerschmitt 110 or something like a Lancaster, if you're doing it with glow engines, then it can be a bugger to try and get everything matched perfectly. So as you throttle up, you get identical levels of throttle from all of the motors. Now what he's done here is in the mixes, he's actually added a curve to both of the engines, curve CV01 and CV02. If I just jump into curves, and again I have a video all about what curves are and how they work, so if any of the information in this video isn't making sense, I strongly suggest go and have a look at the OpenTX Mix School. It starts very simply and builds up, but curve 1 and curve 2 are actually not really curve at all, they're just a straight line. And the process that Clive explained to me, which I think is really, really clever, is what he does is, first of all, he sets both the motors running. He uses a tachometer to check them both. And what he does is the curve for the engine that's a little bit slower at tick over, he would adjust. So say, for example, we have these two engines running on the model and the left-hand motor is engine 1, the right hand motor is engine 2. Maybe engine 2 is a little bit slow on tick over. If you want to change that, then what we could do is go into the curve and increase the throttle signal at that low level. Next thing to do then is to increase the throttle to 100%, and again use a tachometer to see what the RPM is for each of those motors. And it might be this time that we find that the motor 2, and again engine 2 is the one we've just played with curve 02, is maybe a little bit fast now. Now there are a number of ways that you could slow down a motor. You could enrich the mixture slightly so it's running rich. That can present other problems though. You can try and mess around with the higher needle, or you can do it on the radio very simply. And all you need to do, again, in the curves, it's curve 2 for the motor that's running a little bit quick. You can just maybe bring the throttle down until the RPM is pretty close. And then finally, pop the throttle at 50%, and then you can either increase the speed of the slow motor or decrease the speed of the fast motor, and you'll end up with a curve that isn't completely flat, but both of the motors will be matched. Now in Clive's experience, doing it with these 3 points will give you a pretty good match across the entire throttle range. If you wanted to be more accurate about it, then you could use a 5-point throttle curve and actually match the RPM at both the low, mid and high positions, but also the intermediate positions as well. Couple of words of warning with this: do be careful with resonant frequencies. If you manage to get all of your engines running at exactly the same RPM, then what can happen is the vibrations coming out of those props and motors can amplify each other, and if it's at the resonant frequency of part of the airframe, it'll wobble and flap around and potentially cause damage. So there may be instances where you want to be the RPMs to be close, but not exactly the same. So hopefully that's interesting for those of you that are glow engine pilots and use the Taranis. First tip from Clive is to use this curve and add that into the throttle input. That way it'll linearize the throttle output from your glow engine. And then secondly, on your mixes, add a curve to each of the throttles that are controlling your glow engines, and then use those curves rather than the mechanical bits and pieces in your motors to actually make sure that they are completely matched, and you'll end up with a slight difference from a straight line, and you should have equal thrust and equal RPM on both sides. If you found that video useful or like the content, then please hit the like and subscribe button down below. If you want to go the extra step, you can become a Patreon of the Painless 360 channel and help provide support for what I do here. All the videos created here are put into playlists, so if you're interested in a particular topic, have a look at the playlist, and they all are organised in there to make them easier to use. If you're not sure if there's a video for your particular problem or topic you want to know more about, then add Painless 360 to the Google search term that you're interested in, and that should find the video, article or content about the particular thing that you're interested in having a look at.